Hi, I'm Jane Kay, a Senior Scientist at DairyNZ, and this is a feed-right video on protein metabolism. In this video, we will look at the different types of proteins that are found in feeds, what happens when a cow eats protein, and how protein affects cow production and performance. So, let's have a look at the types of protein found in feeds. A protein is basically a long chain of amino acids. In feeds, the protein content that is generally reported is called crude protein and is often abbreviated as CP. Now, it is assumed that proteins contain 16% nitrogen, so the crude protein content is estimated from the amount of nitrogen in the feed. Crude protein includes several protein groups. These are rumen-degradable proteins, which include soluble proteins, undegradable dietary proteins, undigestible dietary proteins, and non-protein nitrogens. First, we'll look at the rumen-degradable proteins. These are the proteins found in feed that can be broken down or degraded by microbes in the rumen. Of these rumen-degradable proteins, some are instantly available to the rumen microbes, meaning that they are degraded and used very quickly in the rumen. These are referred to as soluble proteins. Now, feeds that are high in rumen-degradable proteins are fresh forages and silage. If we move on to the other types of protein found in feed, we have the undegradable dietary proteins, or bypass proteins. As their name suggests, these are proteins that cannot be degraded by the microbes in the rumen. These proteins pass through the rumen unaltered and are then degraded in the abomasum, with the resulting amino acids absorbed from the small intestine. Feeds that are high in undegradable proteins, or bypass proteins, include fish meal, canola meal, and soybean meal. Now, if for some reason these proteins are not degraded or absorbed, they are excreted out in the dung. These proteins are then referred to as undigestible dietary proteins. Now, there's one more group that contributes to the crude protein content in feed. As mentioned earlier, crude protein is estimated from the amount of nitrogen in feed, so it also includes the non-protein nitrogen compounds. These compounds are not true proteins in that they don't contain amino acids. However, they contain nitrogen, and this nitrogen can be used by the rumen microbes and converted to amino acids, which we will discuss in more detail soon. So in summary, protein in feed is generally measured as crude protein, and that is estimated from the amount of nitrogen in the feed. The crude protein content includes the rumen-degradable proteins, including the soluble proteins, undegradable dietary proteins, undigestible proteins, and the non-protein nitrogens. Let's look in more detail at what happens to these protein groups in the dairy cow. We will begin with the rumen-degradable proteins and soluble proteins. These proteins are degraded or broken down in the rumen to form ammonia. The microbes then use this ammonia, coupled with energy generated from carbohydrate metabolism in the rumen, to form their own protein. This protein is referred to as microbial protein and enables the microbes to grow and multiply. The microbes are then flushed from the rumen, through the reticulum and omasum, into the abomasum, where the acidic environment kills them and initial protein digestion begins. Digestion continues in the small intestine, and the resulting amino acids are absorbed for use by the dairy cow. These amino acids that are available to the dairy cow are called metabolizable protein and can be used for many metabolic processes, including tissue function, growth, milk production, and reproduction. Now, what is extra special about this microbial protein, and why ruminants differ from you and I, is that microbes can also use non-protein nitrogen compounds in feed and convert these to microbial protein, which is then available for use by the dairy cow. As with the degradable proteins, the non-protein nitrogens are converted to ammonia in the rumen and then used by the microbes for their own growth. Once again, the microbes also require an energy source, which comes from fermentation of carbohydrates in the rumen. So let's take a moment to recap here. The rumen-degradable proteins and soluble proteins are degraded in the rumen to form ammonia. Microbes use the ammonia combined with an energy source to form microbial protein. Non-protein nitrogens are also converted to ammonia in the rumen and used by the microbes to form microbial protein. This microbial protein supplies the cow with a significant portion of its total protein needs. In fact, a dairy cow can live and produce milk on microbial protein alone. However, there is a threshold to the amount of ammonia that the rumen microbes can use. And if the cow is producing large amounts of milk, she will require protein from other sources, which we will discuss in more detail soon. So what happens if there is more ammonia produced in the rumen than the microbes can use? Firstly, the excess ammonia is excreted out and transported to the liver. As ammonia is toxic to the dairy cow, it is converted to urea in the liver in a process called ureagenesis. Then, depending on the protein requirements of the cow and the protein supply from the diet, this urea will follow one of two pathways. Firstly, if the cow is consuming more protein than she needs, the urea is excreted, primarily in the urine via the kidneys, with a small amount making its way into the dung and also into the milk, which is often referred to as milk urea. In contrast, if the dietary protein is less than what the cow needs, then the urea is recycled back to the rumen, either through the rumen wall or via saliva, and is then used by the microbes to create microbial protein. Generally, this process is well regulated and allows the dairy cow to recycle protein for later use. However, if rumen ammonia levels become too high and too much ammonia enters the bloodstream, this is toxic to the dairy cow and can result in reduced performance, sickness, and even death. Therefore, although supplementation with non-protein nitrogen sources, such as urea, can provide a source of microbial protein for the cow, this must be undertaken with caution and should only be used with appropriate diet control, nutritional advice, and monitoring. So that's what happens to proteins, or non-protein nitrogens, that are degradable in the rumen. They are used by the rumen microbes to generate microbial protein, which is then made available to the cow. Generally, microbial protein makes up about 60% of the metabolizable protein in the cow. The remaining 40% comes from the undegradable dietary proteins, which we'll look into now. As its name suggests, these proteins are resistant to degradation in the rumen, generally through chemical, heat treatment, or due to how the protein is bound in the feed. These proteins pass through the rumen unaltered and into the abomasum, where digestion begins. As with microbial protein, the undegradable dietary proteins are broken down into amino acids, absorbed from the small intestine, and contribute to the metabolizable protein pool that is available to the cow. However, unlike the microbial protein, which has a very consistent amino acid profile, undegradable dietary protein can contain varying amounts of different amino acids depending on the feed source, and can therefore be used to supply specific amino acids in the diet. So, what happens to this metabolizable protein? Once absorbed from the small intestine, the amino acids move into the liver, and in the case of a lactating cow, a large proportion are petitioned to the mammary gland, where they are used to make milk protein. In growing animals, amino acids are petitioned to muscles for growth, and in the case of a pregnant cow, protein is also required for the growing fetus. Now, as always, there are a few exceptions to the rules. When it comes to degradable protein, the amount that is actually used by the microbes depends on both the rate at which the microbes can degrade or digest the protein and the rate at which the protein passes out of the rumen. Therefore, what can happen is that in some instances, some of the rumen degradable protein passes out of the rumen before the microbes are able to degrade and digest it. This then passes to the abomasum and acts like undegradable dietary protein or bypass protein. For example, nearly 80% of the protein in good quality spring pasture is degradable in the rumen, and about 50% of this is soluble protein, so it is degraded very quickly. What we have then is that there is a portion of the rumen degradable protein that is degraded relatively slowly. Now in spring, when cows have a high intake and the pastures have a low dry matter percent, there is a lot of water moving through the rumen and a very fast rumen passage rate. This means that a portion of the rumen degradable protein passes through the rumen and into the abomasum before it has time to be degraded and used for microbial protein, therefore providing a source of undegradable dietary protein for the cow. So in summary, there are several different types of protein found in feed. Rumen degradable proteins that are degraded in the rumen, and of these the soluble proteins are degraded very quickly. We also have the non-protein nitrogen compounds that are degraded quickly in the rumen and used by the rumen microbes. Then we have the undegradable dietary proteins that pass through the rumen unaltered and are digested and absorbed in the abomasum and small intestine. Finally, we have the undigestible dietary proteins that pass through the rumen and are not digested at all. These are excreted out in the dung. So for the cow, this means her protein comes from two primary sources. It comes from microbial protein, which is formed from degradable dietary proteins, soluble proteins, and non-protein nitrogen sources, and from undegradable dietary protein, which supply a direct source of amino acids. This protein is termed metabolizable protein and supplies the cow with amino acids that are used for many metabolic functions. So by the end of this video, you should be able to name the different proteins that are found in feeds, know what happens when a cow eats protein, and understand the effect that protein has on cow production and performance.